All right, so here we go. This first side of the paper, and I'll try not to use my calculator. The parts in gray, you'd probably need your calculator, but we'll see how it goes. All right, so this first problem is a exponential growth or decay. It's a decay because of the 1/4. The base is less than 1, so it's a decay problem. So normally decay problems kind of look like that to start with. They have asymptotes at y equals 0. So the +1 on the end moves your asymptote up to y equals 1. And so I'm going to draw that on there. Okay. So the graph is moved to the left 3 and up 1. So that means that this point right here is moved to the left 3 and up 1. So that would be, I'm sorry, the point used to be right here, and that's moved to the left 3 and up 1. So 1, 2, 3, up 1, now it's right there. Alrighty, so it's just a decay problem, so it's going to come down and go across. So it does not have an x-intercept. We won't have to worry about that. If it did have an x-intercept, I would be plugging in 0 for y over here and then solving this problem using logs, but it's not going to have one. It won't work. All right, the range and the domain. The domain is from -infinity to infinity. All exponential functions, they have domains of -infinity to infinity. All right, and the range is from 1 up, so 1 on up. For your y-intercept, you plug in 0 for x. So if I put a 0 in here for x, I get 1/4 to the third, which is 1 over 64 plus 1. And so my y-intercept is 0 and 1 and 1/64. Okay, and if you needed to, you could put that in the calculator and get the decimal for it. It's continuous everywhere. And the graph is decreasing the whole time. So it's not increasing, it's decreasing everywhere. All right, number 2. So we have e to the x in this problem. So remember, e is just the number 2.714, I think. So it's just an exponential function, a growth problem. So the asymptote here is -3 because it gets moved down 3. Now, this problem, the function gets moved down 3, so right there, but then it gets flipped over that red line because there's a reflection. So actually, if you track that point, it's right here. And normally a growth problem looks like this. It's going to be flipped over, so it's going to look like that. All right, the range is everything below -3, so -infinity to -3. It doesn't have an x-intercept again. And the y-intercept, if I plug in 0 for x, I get negative e to the 0, which would be -1. -1 minus 3 is -4. All right, continuous everywhere. And it is decreasing the whole time, so it's decreasing everywhere. Or you can put -infinity to infinity. All right, over here, number 3, log. So logs, your basic log functions look like this. They pass through the point 1, 0 if you don't move it around, and it has an asymptote of x equals 0. So this asymptote is going to get moved around because this piece right here. So 2x plus 5 has to be greater than 0. So if you take away 5 and divide by 2, you get x is greater than -2.5. So that's going to be my asymptote. So 2.5 right in the middle here. Okay, and so that's your domain, everything to the right of 2.5. I give 2.5. Okay. My range will be everywhere, -infinity to infinity. And this thing that moved up 1. So, like I said, the graph usually goes through there, but that graph, that's going to get moved to the left 2.5 and then up 1, so that means that it's about there. So this guy is going to be looking like this a little bit. So it does have an x and a y-intercept. The asymptote is x equals -2.5. It is only continuous from -2.5 on, and it is increasing the whole time from -2.5 to infinity. All right, so x and y-intercept. So my x-intercept, let's do my y-intercept first. My y-intercept is when x is equal to 0. So if x were 0, I'd get log of 5 plus 1. So log of 5 and then plus 1, whatever that decimal is. My x-intercept is when y equals 0, so it's a little bit different. So I have 0 equals log base 10 of 2x plus 5 plus 1. So take away 1. So that means my left side will turn into -1. So now I have a problem to solve. Write it as an exponent. 10 to the negative 1 is 1/10. So I get 0.1 equals 2x plus 5. If you take away 5, you get negative 4.9 equals 2x. And if you divide by 2, you get negative 2.45. Well, so negative 2.45 and 0. So you can see, it was crossing. Negative 2.45 was right there where I was crossing. All right, so last one. So ln of 4x, so that means that 4x has to be greater than 0, so x is greater than 0. So my asymptote is not changing. It's staying right here at 0. All right. My domain is 0 on. My range is negative infinity to infinity. So this thing gets moved up 2, so it's still going to go through the point. Well, it's not going to go through 1, 0 because that 4 kind of affects you. It kind of stretches you out. And so, but it'll be down 2, so it'll be about here. And so we'll take a look at the calculator, but there's my log graph right there. So it doesn't have a y-intercept this time, but it does have an x-intercept. Because you can't put 0 in for x because you can't do the log of 0. So that's why it doesn't have a y-intercept. All right, my x-intercept. So I'm going to let y be 0. So I get 0 equals ln of 4x minus 2. So bring the 2 over. So ln 4x. So write it as an exponent. E to the 2 equals 4x. So x equals e squared over 4. So e squared over 4 is my x-intercept. You can put it in the calculator if you need to see the number, and 0. All right, these logs here you should be able to kind of do without a calculator. Log 7 to 7 is 1. Log of 0 is non-existent. These guys cancel each other out, so 9. ln e cancels each other out, so I have 3 times negative 7 is negative 21. 3 to the 4th is 81. X to the 1 is x. 4 to the negative 3 is 1 over 64. And these guys, these do not cancel each other out because ln of negative 2 is an illegal question. All right. The top 5 to the 0 is 1. Can't do a log of a negative number, so no answer here. ln of e cancel out to 1. ELN goes away, 8. This next one, ln of e to the 1 over, this could be written as ln of e to the negative 5. So then these would cancel. The answer is negative 5. Remember that radical 3 is like 3 to the 1/2. So this is saying that 27 to some power is equal to 3 to the 1/2. So 27 is 3 to the 3rd. So that means that so 3 to the 3rd has an x right there. So you have basically 3 to the 3x equals 3 to the 1/2. So 3x equals 1/2, meaning x would be 1/6. All right, I can't do log of a negative 100. The last one, remember this is log base 3 of 3 to the 1/2. So 3 to the 1/2 equals 3 to the 1/2, so this would be 1/2. Alrighty. So here, I'm condensing and expanding. So the reason you'd only want to condense and expand is for solving equations. You don't just do it just because. Mostly you condense things when you solve equations. So all these numbers out front will be exponents on these things. This will be a 5. And so here we go. So I have log base 5. The x12 is going to divide with the x5, and it's going to multiply with the 3. So clean that up. I would get 3x to the 7th. Right over here, this x is going to have a 3. 4 is going to have a 2. And then I'm going to have a 1/3 over there. So these are all going to be multiplied. So I have ln of x to the 3rd times 4 squared, which is 16, times 5x plus 2 all to the 1/3. So I have ln of 16x to the 3rd, the cube root of 5x plus 2. Or you could leave it 1/3 power. All right, here I'm going to expand. So there's 3 parts here. I'm going to have log base 4 of 4 plus log base 4 of x to the 3rd plus, and that 3 could actually be out front. I should put that now. And then minus log base 4 of y to the 5th, but the 5 is out here. The only thing I would change here is log base 4 of 4. That can be a 1. All right, here I have ln of e to the 3rd minus 1/4 from my fourth root, ln of 5x minus 2. The only thing I would change is that these go away, so this expression is just 3 minus 1/4 ln of 5x minus 2. All right, last one. So I'm going to have log base 7 of x plus 4. That will be squared, but I'm going to put the 2 out front, minus log base 7 of 5 minus 2 log base 7 of x. And I don't know log base 7 of 5, so it just stays there. All right, some equations. So both 25 and 125 can be written as powers of 5. So I got 5 squared and 3x plus 2. I got 5 to the third and 4x. So really I have that 6x plus 4 is my exponent here, has to equal 12x on the other side. So I have 6x equals 4, so x must be 2/3. All right, over here, I have move the 2 and get a 12. So 3 to the x plus 4 equals 12. 12 is not a power of 3, so I'm just going to have to take the natural log of both sides. So when I do that, the x plus 4 comes down in front of the ln 3 equals ln 12. So I'm going to divide the ln 3 over, so x plus 4. Oh, I don't need parentheses anymore. Equals ln 12 over ln 3. So I would divide those in my calculator. It comes out to 2.26, and then take away 4. So that's negative 1.74. All right, over here, if you write this as a quadratic, minus 15. So this is a quadratic. You can equate it to this, x squared minus 2x minus 15. So when you factor that, you'd know you'd need whatever you're squaring, which is e to the x, and you have to make 15, but also make 2. So you'd want minus 5 and plus 2. So I would get e to the x minus 5 equals 0. So I have e to the x equals 5. So I take the natural log of both sides. ln here, ln there. ln of e cancels, so I get x equals ln 5. That's a valid answer. Over here, I get e to the x plus 2 equals 0. So e to the x equals negative 2, which is not possible. So one answer. All right, letter D. I am going to bring this log 6 of x to the other side, so leave the 2. I have log base 6 of x minus 5 plus log base 6 of x. So I can multiply those logs, those pieces together. So I have log base 6 of x times x minus 5 equals 2. So basically have 6 squared, which is 36, equals this expression here. Well, that's x squared minus 5x. So I end up with x squared minus 5x minus 36 equals 0. I factor that. I get x minus 9 and x plus 4. So my answers are 9 and negative 4, but this was a log problem, so be careful. You can't put negative 4 here, you can't put negative 4 there, so you would exclude him as an answer. 9 is the only answer. Letter E. Letter E, I'm going to bring this guy over here and put the 3 on the other side. So I have log base 5 of x squared over 8 minus log base 5 of x over 40 equals 3. So I'm going to end up dividing the logs on the left side. So I'm going to end up having x squared over 8 divided by x over 40. So let's just take care of that now. So x squared over 8, that turns to times 40 over x. So everything cancels out, the 8 and the 40, the x squared and the x, so you end up getting 5x. So when I put these together, I have log base 5 of 5x equals 3. So I got 5 to the third, which is 125. So 125 equals 5x, so x must be 25, which is fine. All right, over here, log of x to the third plus 7 can stay here. These other two can be put together. This is log of x to the third, because I'm going to take that 3 away. So I have log of x3 over 5. So now that I have logs equal to a log, I can drop the word log. I just have x to the third plus 7 equals x to the third over 5. So I'm going to multiply by 5. I get 5x to the third plus 35 equals x to the third. So let's see. I'm going to take away x to the third, so I got 4x to the third, move 35 over, negative 35, divide by 4, negative 35 over 4. Just take the cube root. So x equals the cube root of negative 35 over 4, a negative answer. It's perfectly fine to have, oh, no, wait a minute. This is going to be a negative answer, so I cannot put a negative number right here. So actually, this one has no solution. This is extraneous, and it's the only one I have. So no answer. All right, last one here. They're all logs, so I need to condense all this and then drop the logs. So it's going to be ln of 2x times 4 minus 16 over x equals ln of x minus 2 squared. So now that I have that together, I'm going to drop these ln's. So I have 2x, 4 minus 16 over x equals x minus 2 squared. So some algebra left. All right, let's see. So I will multiply this out and get 8x minus 32 equals x squared minus 4x plus 4 when you multiply this out correctly. All right, so I'm end up with x squared minus 12x plus 36. And so when I factor that, that is x minus 6 both times. So the answer is 6. So just make sure that 6 is okay. If I think about it here, that's fine. Think about it here, that's fine. Think about it here, that's fine. So good to go. All right, so don't forget, you got these equations to know how to do. I will give you the equations, but you need to know how to use them. And just like you did on your, with your partners that one day. I'll see you in class. Bye-bye.